about database sharding. So database sharding is a process of storing large database across multiple machines. When you store data on a single machine or a database server, you can only store and process a limited amount of data. But database sharding overcomes this limitation by splitting your data into smaller chunks called shards and storing them across several database servers. All the database server usually have same underlying technologies and they work together to store and process large volumes of data. So now let's look out for benefits. So first is improving the response time. Data retrieval takes longer on a single large database. The data management system needs to search through many rows to retrieve the correct data. By contrast, data shards have fewer rows than the entire database. Therefore, it takes less time to retrieve specific information on a sharded database. The next benefit is scale efficiency. So, a growing database consumes more computing resources and eventually reaches the storage capacity. Organization can use the database sharding to add more computing resources to support database scaling. They add new shards at the runtime without shutting down the application for maintenance. The next benefit is preventing a system failure. If the computer hosting the database fails, the application that depends on that database will fail too. So, database sharding prevents this distributing by distributing parts of the database into the different computers. So, failure of one of the computer does not shut down the entire application because it can operate other functional shards. Sharding also oftenly involve combination with the data replication across the shard. So if one of the shard becomes unavailable, the data can be accessed and restored from the alternative shard. So now let's look at how the sharding works. So database stores the information in the multiple data set consisting of columns and rows. So database sharding splits this single data set into multiple partitions of the shards. Each shard contains unique rows of information and you can store separately across multiple computers called nodes. So all shards run on separate node but share a original database scheme or design. Now let's look out for the key component which is involved in database sharding. So first is shard. This is the data chunk which is created after partitioning of the database. These are called logical shards. But the machine that store these logical shards are called physical shard or a database node. So physical shard can contain multiple logical shards. And the next component is shard key. A software developer uses the shard key to determine how to partition the dataset. A column in the dataset determines which row of the data should be grouped together to form a shard. Database designer choose a shard key from an existing column or can create a new one. So database sharding operates on a shared nothing architecture. Each physical shard operates independently and unaware of the other shards. Only the physical shard that contains the data that request will process the data in parallel for you. Software layer coordinates data storage and access from multiple shards. For example, some of the types of the database technology have automatic sharding features built in it. Software developers can also write sharding code in their application to store or retrieve the information from the correct shard. Let's look out for the types. First is your vertical scaling. In this method, we split the entire column from the table and we put these columns into new table. So data is totally independent of one partition to other partition. Also, each partition hold both distinct rows and distinct column. In this method, you can separate and handle critical and non-critical part individually and build different replication consistency model around it. This is one of the major advantages of this method. The main drawback of this scheme is that to answer some of the queries, you may need to combine data from different shards, which is unnecessary and increases the development and operational complexity of the database. Also, if your application will grow later and add new features in it, then you will have to further shard a feature specific database across multiple servers. So let's look out for the next type, which is horizontal or range-based sharding. In this, we split the data based on the range of a given value inherent in each entity. So this is one of the simplest sharding method. Every shard holds a different set of data, but they all have same schema. In this method, you just need to identify in which range your data lie, and then you can store that into a corresponding shard. This is best suitable for storing non-static information, like storing contact information of students in a college. The drawback of this method is that it is not always evenly distributed on shards, because in some cases few shards may have more workload than other. Then it becomes a system bottleneck. Other method is a key based or hash based sharding. So here we take a value of an entity such as customer ID or email, and we use this value as an input of hash function. This process generates a hash value which is used to determine which shard should we keep this information in. We need to keep in mind that the values entered in the same hash function should all come from the same column or shard key. This is just to ensure that data is placed in the correct order in a consistent manner. Basically, shard key acts like a primary key or a unique identifier for individual rows. Consider this example when you have three database server and each request has an application ID which is incremented by one every time a new application is generated. To determine which server data should be placed on, we perform a modulo operation on these application ID with the number 3, like shown in the figure. So then the remainder is used to identify that which server should we use to store our data. So the downside of this method is elastic load balancing, which means you will try to add, or if you try to add or remove the database server dynamically, it will create difficulties and it will be an expensive process. For example, if you want to add 6 more servers, then majority of the keys would need to be remapped and migrate to a new server. Also, then you need to change your hash function from modulo 4 to modulo 10. So, but this problem can be solved using the concept of consistent hashing. So next we will move to directory based sharding. In this method, we maintain a lookup service or a lookup table. Basically, we use a shard key in a lookup table and we do mapping for each entity that exists in the database. In this way, we keep track of the database shard, that which database shard holds which data, and the lookup table holds static set of information about where the specific data can be found out. So this is more flexible than range based or key based sharding, because in range base you are bound to specify the range of the value. In key base you are bound to fix a hash function which is difficult to change later on. In this approach you are free to use any algorithm you want to assign to data entries to shards. Also, it's very easier to add shard dynamically in this approach. The major drawback of this approach is a single point failure of the lookup table. If the lookup table gets corrupted or failed, then it will impact the writing new data or accessing the existing data. Now we will look out for the method for optimizing the database sharding. So when the data overload occurs on a specific physical shard and some of the physical shards are underloaded, it results in database hotspot. So database hotspot slow down the retrieval process on the database, defeating the purpose of sharding. So good shard key selection can evenly distribute the data across multiple shards. So when choosing a shard key, database designer must consider these are the following factors so that there is an even distribution. First is cardinality. It describes the possible values of the shard key. It determines maximum possible number of shards on a separate column oriented database. For example, a database designer chooses yes no field as a shard key, so the number of shard is restricted to one. Then you have frequency. It's another factor. It's the probability of storing specific information in a particular shard. For example, database designer chooses age as a shard key for a fitness website. So most of the records might go into the nodes that subscriber who are aged from, let's say, 25 to 45, and that results in a database hotspot. Another factor that can optimized database sharding is monotonic change, like which can affect our performance of database sharding. So that is monotonic change. So this is the rate of the change of the shard key. A monotonically increasing or decreasing shard key results in unbalanced shard. For example, a feedback database is split into three different physical shard as follows. So this is an example where I'm taking feedback database, and it has basically three shard. So shard 1 stores feedback from the customer who have made 0 to 10 purchases. The second shard stores feedback from the customers who have made, let's say, 10 to 20 purchases. The third shard shows the feedback from the customers who have made, let's say, more than 20 purchases. So as the business grow, customer will make more than 20 purchases. So the application store the feedback in the shard 3. Like in the third shard there will be more of the information, and the other will be underloaded. So this results in unbalanced sharding, and this is what you need to take care while designing a database. So these three factors should be taken care of so that your shards are evenly distributed. Lastly, we'll look out for alternatives of the database sharding. So as we know, it's a horizontal scaling strategy that allocates additional nodes or computers to share a workload of the application. Organization benefit from the horizontal scaling because it's a fault tolerance architecture. When one computer fails, the other continue to operate without any disruption. So database designer reduce the downtime by spreading logical chart across multiple servers. However, it is one of the several other database scaling strategies. Let's explore the other ones. So first is vertical scaling. It increases the computing power of a single machine. For example, IT team adds more CPU or more RAM or more hard disk to a particular database server to handle increasing traffic. Let's compare this with database sharding. So it's less costly because there is a limit to computing, but there is a limit to computing resources that you can scale vertically. Meanwhile, sharding is a horizontal. It's easier to implement, and the IT team install multiple computers instead of upgrading the old computer hardware. So this is an example when you prefer horizontal scaling like sharding over a vertical scaling because of the one of the two reasons, because it's very limited, because vertical scaling cannot be extended up to a certain point, because you can extend a RAM or a CPU or hard drive just to a certain extent. So, and then next strategy is replication. It's a technique that make exact copy of database and stores them across different computers. So database designer use this replication to design a fault tolerant system. When one of the computer hosting the database fails, the other replicas remains operational, and replication is a common practice used in distributed computing systems. Now, let's compare this with the database sharding. So in database sharding, we generally do not create copies of the same information. We just split the database into multiple parts. But and unlike replication, the database sharding does not result in high availability. But sharding can be combined with this replication to achieve both scale and high availability. In some cases, database sharding might consist of replication of subspecific dataset. The last one is partitioning. So it's a process of splitting the database into multiple groups. Partitioning is classified into two types. Horizontal partitioning splits the database by rows. Vertical partitioning creates a different partitions of the database columns. So this was all about sharding in today's video. Thank you for watching. Have a good day.